Hello and welcome to the fifth part in week 2 of NodeJS course for Hack Your Future. Now in this part we are going to talk about uh, APIs. Uh, do you already know what an API is? So API stands for Application Programming Interface. If that was your answer, that's pretty good. So what does this mean? So you probably interface is just a way to connect to things, and you've probably already heard of the term user interface or GUI, and so it stands for graphical user interface. The difference between the application programming interface and the graphical user interface is that the application programming interface is a way for other applications to talk to each other, while the graphical user interface is meant for people to talk to the application. Uh, so while the graphical user interface has a certain look and feel, the application programming interface is usually some kind of URL and a combination of request methods and the request bodies which need to be sent to get a certain response. In the context of the web API, the URL together with the path is called an endpoint for that API. So whenever you're writing a web application, the goal here, there will be no user interface for the application on the server. So the user interface is all living in the browser, and the way to connect the two worlds is by using these APIs. So when you're writing the server side or the backend side, the goal is to write a set of APIs that the browser can use to talk to your server. Of course, this also has to be documented so that the person who is writing, who's building the user interface part, knows what type of APIs there are, how to talk to them, what type of request they need to send, is it GET, is it POST, and so forth. What type of data needs to go in the request, what type of headers there need to be, and what kind of response they can expect. So here is a useful analogy. I'm just going to read it. So to think about web APIs, it's basically kind of a gate through which every request goes through, and it's a single point of contact. So when you, as a client or as a person, you go to the restaurant, you are not allowed to go into the kitchen and cook your own food. However, you're allowed to talk to the waiter, which in our analogy is the API, and the waiter is then allowed to go to the kitchen and pass on your request. And then inside the kitchen, the people working there, they will, based on your request, use the equipment there, use the raw ingredients to prepare the food. And then at the end, once the food is ready, the API or in the restaurant, the waiter will bring you the food. And the food is basically the response to your request. I think this is a useful analogy, and the key thing here to keep in mind is that you, as the user or as the person, don't have access to everything in the kitchen. What you can do is ask for a certain dish, which is available on the menu, ask the waiter for the dish, and then you will get the food after some time. But you're not allowed to go into the kitchen in a restaurant and cook for yourself. And again, keep in mind that in order to know what you can order, you need to have a menu. And this is the API documentation serves as kind of a menu so that the person who is doing the front end or the user interface knows what kind of request he needs to send to the server. That is a bit generic for web APIs. So this applies to every web application out there. They all have a web API. In recent years, it is a standard to use a certain type of architecture to build and design APIs for the web, and that is based on REST, the concept which we discussed at the beginning of this week. And this type of building APIs is called Restful API. So this is just a really fancy term to say that our API follows the guidelines that are described by REST. And if you remember from the beginning of this week, so there are two most important things, and that is that we have a set of resources in our application, and that we have a set of operations that a user can perform on those resources. Now, again, it's important to make a distinction between the resources as a set, for example, users, and a specific user in that set. And whenever we are talking about a specific user, then we usually need to have a way to uniquely identify them uh, within the system. And usually when you want to do a certain operation on a specific user, this is passed in the URL of the request. For example, if I want to update a certain user, then the user that I want to update will be stated in the URL using the identifier that we have chosen for that user. I know this is still a bit abstract, so now we're gonna go very practical on this and very concrete. So imagine that there is a REST API for a library, and so then the host would be library.edu. Yeah, so this is the host that we have for our server. Now it's a library, so the resource is books. Now every resource basically needs to have a separate path in the API. So for example, to do anything with books, we need to use the books part in the path of the URL. So then our URL becomes library.edu/books. Now, if we want to read out information on a certain book, then uh, sorry, on the books, not on a certain book, but on all the books, then we are going to send a GET request to this URL, and we expect that the server will give us a list of books and some information on those books, like for example, a title or an author. If we want to create a new book, then we are going to use the same URL, but then we are going to send, instead of a GET request, we will send a POST request. And inside the body of the request, we will send the information about the book that we want to create. Now, if we want to update a specific book, then we need to identify the book, and that is, as I said, done in the URL. For example, this could be using the title of the book, in which case the URL would become library.edu/books/the White Castle, which is the title of the book or the identifier of the book that we want to update. And in this case, the HTTP method needs to be put, and in the body of the request needs to be the new data that we want to update. Similarly is for delete. So if we put all this together in a table, and this is really the most important part of this lecture, so we have here the type of operation that we want to do, the matching URL for that resource, and the HTTP method that we need to use. So to read data or to get all the books, we send the URL is /books and the method needs to be get. If we want to create a new book, then the URL is the same, but the method changes to post and the body needs to contain the data for the new book. Remember, the GET request has no body, so in this case there is no body. if we want to update the information for a specific book, and in this case, the URL has to have some way to identify which book we are trying to update. And in this case, we need to use a put method. Finally, if we want to delete a specific book, again, we have to specify in the URL the exact book that we are trying to delete, and then use the HTTP method to delete that book. So this is really important. The books part refers to the resource as a whole, and then after that we have a part which refers to a specific book within our resource set. It is a very important concept to distinguish between these two things and how the URL needs to be constructed for a certain operation. So I'm using here the word URL a lot, but the URL, as I said, has different parts to it. The first part is the host, and then everything after this slash is called the path. And also sometimes you will hear the term endpoint or route, and this also usually refers to this second part of the URL. Okay, so now this is how it should look like for an imaginary library. And what I would like to do is take a look at a real web API and see how that one is set up. So I'm going to open a few links here that are talking about the GitHub API. So we did in the previous parts an exercise where I ask you to list the types of resources that you expect to find on GitHub. And I have here now opened the GitHub API documentation, which lists the resources and the types of operation that are possible. So one of the resources is repositories, and this is a really central resource. And for example, we have all the operations that you would expect. For example, you have create, where is the create? Create a repository. For example, it says create a repository for the authenticated user. Yeah, and here is the documentation. So it says create a new repository for the authenticated user. Now I didn't talk about authentication. So that's not part of this course, but keep in mind that for a lot of these operations, you usually are only allowed to do them if you can prove that you are a certain user, so that you need to log in basically to be able to do the operations. So if you want to create a new repository, then you use the URL user repos and you use a post request. And then in the body, you need to send a name, which is required, then description, homepage, and a bunch of other things which you can send in the post request. And here is an example. So to create a repository that says hello world, you need to send this request to this URL with the HTTP method post, and then this will create a repository for you. And there is also the response here. For example, the status will be 201 created, and there will be some extra information about the created repository. The most important one is the ID of the created repository. So the ID, because this is the ID that uniquely identifies your repository. So this is the create part, and there are a lot of options here. Let's see, list repositories, for example. So you can list again all the repositories for a certain user. and use the HTTP method get and the same URL, and you can pass some parameters for sorting and so forth. I'm looking at the response here. Here is an example response. The response is 200 OK, and then you have a list or an array of repositories. So this is one repository, and there will be more of these repositories in this list that you're reading, and you get all the details about these repositories. Maybe it's good if I put all of this together. So GitHub API. Yeah, we have get. So create a repository, and then if you want to read all repositories. Oh, sorry, this is the read. Yeah, of course. And this is the read. If we want to create, I'm gonna go back to the create real quick. Here is the create. This is a post. Right, and this is, for example, a sample request. I think. Let's put this in here. Right. Now in the read, there is no more information in the request because the get request does not have a body and does not need a body. But in the post request, you always have to send. Usually, I have to send a body, and in this case, the body is in the JSON format. Okay, and then we have an update repository. Now here they're using patch. In our course, we will mostly use put for update, but it is also common to use patch. I'm not going to go into discussion which one is correct. Everybody has their own opinion there, but just keep in mind that both put and patch are used for updating. But in this course, I will ask you to use put. So when you want to update a repository, now you see the link is changed. And when you see these two dots here, this does not mean that this needs to be the exact URL, but actually this means that here should be the ID of the repository that you're trying to update. Let me see if there is a concrete example here. No, not really. But for example, if we would like to update an existing repository, let me find one. For example, this ID that they use everywhere. So the actual URL that you need to send should be repos. And then this also means the ID of the owner. Now let's say that's me. And then the repository number. Let me make this a bit bigger. Yeah, so this is how it is written in the documentation. But when you are using this API, you need to substitute all the parts in the path where there is a what is this called? This character at the beginning. You need to substitute this with the actual identifier for that resource. For owner, that's a user, so that might be the username, and the repo is the repository ID, in which case that's a number that uniquely identifies that repository in GitHub. So very important to remember that. We will see that in the exercise as well. And that's update and delete. I'm guessing delete is similar. I'm not even sure if there is a delete. Let me check real quick. Here I found a delete. Yeah. So the delete uses the same URL. Again, delete a repository. So again, this needs to be replaced with actual values for the ID of the repository and for the owner of the repository. Okay. So that was the example with create, read, update, and delete. How that makes it a bit clearer for you. How these URLs are built, what kind of method you need to use, and what needs to go in the request. So it's not important now to remember how GitHub does it, but the concepts that when you want to create and when you want to read, you use a certain URL, and when you want to update or delete, then the URL should contain a part which identifies specifically the object that you're trying to update or delete, and also the fact that you use the different verbs for every operation that you're trying to do. So this is something that you need to remember from this exercise. So let me go back to the README if I can here. Week 2. So we did the library part. Okay. Now as an exercise for you, and I've helped you a lot here, try to write down these endpoints in the same format that GitHub writes their endpoints, and think about what kind of data you would like to send, for example, to when creating a new book. So write this down, all the endpoints, and here this is a concrete example, but write the endpoint in the same format that GitHub does with the two dots. And also think about which of these needs a body in the request, and what kind of data does the body need to have. And you can use JSON format for that. So that's the exercise for now. And in the next part, we are going to actually start with this definition here. Then we are going to build a real application that implements all these different operations using Node.js. Thank you very much.